Thank you for joining the Fire Suppression Systems Association, our webinar on advanced detection using video analytics and integration with other technologies. Your phone lines have been muted. If you have any questions during the presentation, please type them in the question box on the bottom right-hand side of your webinar control box, and we will take them at the end of the presentation. This webinar is being recorded and will be available to download after the presentation is over. With us today, we have our webinar chair, Todd Stevens with Canestraro, and our presenter, Rick Jeffress with Fike Corporation. I'll now turn the mic over to Todd.
Thank you, Becca, and welcome everybody to today's webinar. Appreciate you guys all being here today. Just a couple quick announcements before we get going. I'm really excited to announce that registration is currently open for attendees and the Partner Expo for the 38th FSSA Annual Forum. That forum is going to be held February 20th through the 24th at the Margaritaville Resort in Kissimmee, Florida. I'd encourage everybody to go to the FSSA website. There you'll find the exciting schedule that we put together for this forum. You'll find hotel information, sponsorship opportunities, call for presenters, and more information on the Partner Expo. This event will fill up fast, so again, please get to the website and register when you can. Next, I want to thank our sponsors for today's webinar, BFPE International. For 50 years, BFPE International has been a full-service fire protection systems and equipment supplier and installer with an emphasis on providing solutions for the special hazard fire protection industry, including specialty smoke, fire detection, and controls. Encourage you to reach out to Justin Erdman, who's on the slide here, his contact information for more information on our sponsor. So thank you again to BFPE for sponsoring today's webinar. With that said, I would like to introduce our presenter today. Again, our webinar is on advanced detection using video analytics and integration with other technologies. Our presenter is Rick Jeffress, who is the Director of Business Development for Video Analytics at Fike Corporation. Rick currently resides in Houston, Texas, and has over 26 years in the fire protection industry. He's held positions as International Construction and General Manager, Special Hazards Marine, Marine Offshore, and Sales Manager. He holds NICET Level 3 in both fire alarm and special hazard suppression systems. He is a certified fire protection specialist with NFPA, with secondary education at University of Maryland and risk management at the Institutes. He currently is on a number of committees, including the Installation Standard for Video Image Detection. With that, I'd like to pass the presentation over to Rick. Rick?
Thank you, Todd. Thanks to FSSA for inviting us to present video analytics and how we're integrating it with other technologies. Thanks again to BFPE as the sponsor. So I'll be talking today about video analytics, where it's used, how it's used, how we apply the technology to different applications, how the layout, how we develop a price to bill of material, approvals. We'll also be talking about new technologies that are being integrated with video analytics. We're very excited about a line of flame detectors that have IP HD video available that can be analyzed by the analytics to supplement the radiant energy detection with video analytics for smoke, oil mist, reflected flame, and flame detection. I'll also be talking about thermal radiometry that's beginning to be used as early fire detection and how video analytics is integrated with thermal radiometry to give you early detection and supplement the detection that's provided with the video analytics. The video that you're seeing now is the UL test facility. The engineer lit a 4-minute calibrated smoke emitter. Video analytics analyzes the entire field of view of the screen of the image. All the pixels are being analyzed with all the algorithms that are enabled. The field of view of a video analytics camera is shaped similar to a pyramid. So it's about 82 degrees field of view horizontal, 64 degrees field of view vertical. As you can see, the image is floor to ceiling here. Now, if you look at a spot smoke detector, the effective alarm area of that detector is the space between the diode, where the smoke has to reach at the correct obscuration to affect an alarm in the detector. For video analytics, the entire field of view is the effective alarm area. The system can alarm anywhere. Now, if you notice, the smoke did not reach the ceiling. It's obviously stratified, so detectors at the ceiling may not detect the smoke. The smoke may not reach the ceiling, either due to a thermal layer holding the smoke down or not enough energy to propel the smoke to the ceiling. So high ceiling applications, large volume spaces are a great application for video analytics due to the large area of coverage. Video analytics is used in many applications. In the upper right-hand picture, you see a video analytics camera looking at the caps to make sure that the caps are on correctly. Lower right, video games to see, watch your body movement with the game. Security systems, obviously, in airports, they have queuing, bag left behind, many uses for video analytics in the security business. In the lower right-hand corner, you'll see a heat map. So you go to a major retail store, you'll see cameras. Many times those cameras will be monitored by video analytics to monitor for dwell time around the stands or traffic flow. There's a company in Singapore that does this in the cloud. So we're doing this, we're analyzing the image the same as all these other technologies. We have light and light level as well as color on the image to work with our analytics. Video analytics is used in a wide range of applications, from power, electrical equipment rooms, tunnels, turbine decks. About half of our sales are into the marine and offshore market, specifically monitoring for oil mist, reflected flame, and smoke in mechanical equipment rooms. It's primarily around engines and boilers, fuel purification systems. Mechanical equipment rooms are a good application, high ceiling, large volume spaces. Waste facilities are, our system is in about 50, video analytics is in about 50 waste facilities that I know of. We're also seeing a lot of use of the IIIR detectors because of the stability of the detector and fast response. Cultural, in cultural applications, A few cameras are installed on the walls, covering the entire space. Indoor process areas are also used with video analytics, manufacturing, heavy industrial. Now, from a Fike perspective, we only use our video analytics indoors. We can't control natural lighting. We need at least 1 foot candle of light to see smoke and motion. So we are looking for a stable lighting environment. Therefore, we use our analytics indoors only. So video analytics is a unique detection method, and we understand that end users, fire protection engineers, distributors don't deal with it every day. So we like to be involved with from the concept stage of the application, discuss the application with our customer, determine mutually if the technology is right for the application. If it is, a layout can be provided, design information and a price bill of materials provided. When the system is installed and video in the software, we like an audit report with images from the system sent to application engineers. So as soon as the system is installed, recommendation on camera settings are provided to the technician. The technician is also trained on the specific site and how the analytics are being used per camera, and then stay with the technician until the system is signed off. The algorithms available are smoke, which are also used with oil mist, flame, reflected flame. Reflected flame with video analytics is the only means that I know of to detect reflected flame, unless it's a very large fire and you're using a radiant energy detector. Motion is also available. Within the software, there are settings to monitor the areas with the highest detection sensitivity and the lowest potential for false alarms. So a difficult application for any technology is a plant where they make car parts out of molten magnesium. So in this view, the building is over 40 foot high. It's a smoky environment, and there's a flame normally in the process. So you wouldn't be able to use smoke detectors, heat detectors, or radiant energy detectors. So with video analytics, a camera is placed in the facility, record for about a week, go back and find the areas where there's a flame in the process. We add a masking zone over that flame and tell the system, set the system up so that if it sees a flame in the mask zone, it doesn't go into alarm. But if the flame grows and breaks outside of the masking zone, the system goes into alarm because it's been tracking it. Now, nights and weekends, there's a schedule so that all the blocking zones can go away. So it's alarming for flame in the entire field of view. Smoke detection can be enabled on nights and weekends, and then a motion detection zone can be enabled as well for security. Now, this is an example of a reflected flame algorithm. So if you had a radiant energy detector in this space, the energy would be blocked by the stack of material from reaching the radiant energy detector. Video analytics can supplement radiant energy detection or be used on its own to detect the reflection of flame off of reflective surfaces. So in this case, the purple dots represent the reflected flame algorithm. It's very good in spaces where there's a lot of obstructions, mechanical equipment rooms, for example. The way that video analytics analyzes for smoke is if you look at the left-hand screen, analytics are monitoring the image 15 frames a second and looking for an organized group of pixels having a light level change, moving in an organized pattern consistent with learned smoke algorithms. Now, we do that by tracking the amount of time the pixels are affected. On the right-hand image, you see the orange represents pixels that have been affected the longest. They're closer to the fire. The blue pixels represent pixels that have been newly affected and farther away from the fire. So tracking the amount of time the pixels are affected. So a typical turbine deck application, you can see some oil was burned off on a lower level. The smoke migrated into the space. In this case, there are two cameras, one camera looking at this side of the turbine, and then a camera down the wall looking at the other side. High voltage tunnels are a great application for video analytics. A few years ago, the Atlanta airport suffered a power outage for the entire airport. That was a result of a high power power line splice explosion in the tunnel. There was very little fire detection. The airport was required to spend some time to find the area of the event. Investigation had to be performed to make sure that it wasn't terrorism, an investigation. And then the power company was allowed in to make the repairs. So 107 video analytics cameras were installed in the tunnels, spaced at 100 feet apart, monitoring for smoke, flame, and reflected flame, as well as motion, because it's a very stable environment and people aren't down there very often. So with the video analytics, the system is recording 24/7, 365, so that if there is an event, it's recorded. The airport will know exactly the location of the fire or the explosion for the event. And then they have post-incident analysis used with the recorded video. This is an example of a typical shipboard system. The main reason for video analytics on ships is for oil mist detection. It looks very much like smoke. In this event, it could be oil being burned off the heads after maintenance. It could also be an exhaust leak or oil mist. Smoke detection is being used in waste facilities now that there are a lot of increased amount of fires in waste facilities due to lithium batteries. So this is an example of video analytics smoke detection being applied. High-rise mechanical equipment rooms or any mechanical equipment rooms are a good application for video analytics. In this image on the bottom right-hand side, that's the fire department acceptance test, the smoke emitter, the smoke rising, moving into an alarm zone. So the other pictures represent areas of detection, smoke, flame, reflected flame. The box at the top of the image, that's a smoke detect or alarm zone. The smoke is generated on the floor, tracked, and as soon as it reaches the alarm zone, the system goes into alarm. I mentioned oil mist. This video is of an injector from a large cruise ship engine spraying simulated fuel. So you could clearly see the blue outline of the smoke. That's an initial algorithm. you'll see the clear tiles. Those represent a higher sensitivity algorithm that's used to hold the detection longer or require the smoke or oil mist if it's lost. So higher sensitivity in the areas of detection. The alarms available for video analytics, flame, reflected flame. There's only one company that I know of that has video analytics that has the reflected flame algorithm. Oil mist, spray, and motion detection. Now, we often detect a water spray as well because that looks very similar to smoke in some cases. Trouble conditions can be caused by an image change. Image change meaning if there's no contrast. So the system needs dark and lights in the image to stay out of trouble. Loss of camera connection to the NVR. If the lens is dirty, out of focus, if there's a low light level, lower than 1 foot candle, if there's an internal failure to the camera or the NVR or loss of power can cause trouble conditions. Video analytics require 1 foot candle of light measured at the floor according to the code or the standard for smoke or motion. Flame, reflected flame create their own light, so can be used in dark conditions. LEDs are applied commonly because they have a low power consumption and they can light up the area sufficient for detection. So an example of a listed camera, the UL and FM standards require a 1 foot candle, a 1 square foot pan fire of heptane detected at 100 feet and a 4-minute smoke emitter detected at 100 feet. So the detector is powered by 24 volts DC. There are alarm contacts on the back. The alarm contacts for this camera, there are 3 alarm contacts. So relay 1 can be smoke or flame or any algorithm. Relay 2 is trouble. And then relay 3 can be a separate algorithm from relay 1. So say smoke on 1, 3 on 5. So flame on 3, so that you can differentiate at the panel whether it's a smoke or a flame alarm. Now, video analytics cameras are a listed NFPA initiating compliant device, so can be connected to a releasing panel. So there aren't any standards or requirements for listing for releasing for the detectors, it's for the panel. So the common configuration is the fire alarm panel, 24 volts DC to the detectors, your SLC monitoring alarm and trouble. Ethernet is run to an NVR that's recording a video, tracking events. There's a video management software on a computer where you can view live video, configure the camera settings. The inspection and maintenance, annual, semi-annual, is performed in the software at the computer. Semi-annually, you run an audit report and verify the configuration matches, that current conditions match the commissioning. Annually, the report is run again to confirm that the settings are the same as at commissioning. And we force alarms to the detectors so that we can test the communication between the relay on board the camera, the monitor module, and the fire alarm panel. So other than using video analytics embedded in a camera, video analytics are also available server-based. We have customers that use virtual servers where our software is installed. ONVIF is a global communication standard that IP devices comply. Video analytics software is certified to ONVIF standards, so plug and play with off-the-shelf cameras. So here is a couple of examples of standard Axis, could be Bosch, Pelco, Hikvision cameras. They're IP, ONVIF compliant, can be monitored directly by a server. Now, the new flame detector has an ONVIF HD video camera, so Ethernet can be run to it, to the server, and the analytics performed on the video on the detector. So the detector is classified area, class 1 div 2, wide temperature range, negative, I believe, 67 degrees to 188 F. So when you put the detector in a classified area or a temperature rated area, you're also installing an HD camera that can be monitored with the analytics. A standard configuration, you have the existing cameras and their server. Add a video analytics server with a relay that activates on smoke or flame alarm. And then when there's an event, video analytics software pops up on the screen indicating the analytics overlay and where the event's taking place. So this is an actual event on a ship. There was an oil mist leak up on a upper deck. On the right-hand side, you can see the oil mist being detected. On the left-hand side, you can see that there was a flame also on the other side of the engine. So the crew in the engine control room received an alarm with a video pop-up of the event. They quickly analyzed the situation, activated the local application water mist system, knocked down the oil mist, and the fire was actually put out with a fire extinguisher. This event was, if you look at the bottom left-hand corner, you'll see the date. It was about 10 days ago on a bulk carrier ship. So this is video analytics detecting a flame in service. Video analytics have been complemented with human recognition. So in this case, there are 2 human recognition algorithms added to the smoke detection algorithm to avoid false alarms for smoke from people moving close to the image. So you'll see the yellow outline and the orange tiles. Those are the 2 human recognition algorithms that avoid false alarms for oil mist or smoke with people moving around in these small spaces. So UL and FM have approvals for video analytics. UL 268B is specific for video analytics smoke detection. UL uses FM 3260, which is the radiant energy flame standard. And then FM has a new standard 3232, which includes both video smoke detection and flame detection. FM datasheet 548, represented here, specifically recommends using video image fire detection in industrial applications. Now, they mention outdoors. We do not recommend using our analytics outdoors, even though they are approved and tested outdoors. We're careful when we use it outdoors. However, indoor applications, industrial plants, turbines, etc. NFPA 72 does discuss video image smoke detection and video image flame detection. The standards are very simple, very similar to the requirements of other detectors, communication, backup power, etc. video image flame detection. In NFPA 72, there is a recommendation of a performance-based design that does not have to include modeling. The NYFD requires a performance-based design submitted with a video image detection system design submittal. That's accomplished by stating the goals and how we're going to reach the goals. It's all in a template that we've put together. Can be used for any application. So comparative testing has been accomplished using video analytics in a high ceiling application, tested against aspiration detection, spot detectors being linear detectors. We don't see video analytics as a competitor of aspirations fire detection. If it's a high ceiling application, it makes sense for video analytics because video analytics can analyze the image floor to ceiling and detects as the smoke is rising and alarms way below the ceiling. In high flow airflow spaces, we don't use video analytics because the smoke will be broken up or removed from the space altogether, and we won't be able to detect it. So in this 18-foot ceiling application, video analytics detected the fire and smoke 88% of the time faster than the other technologies. So in this case, the only location where video analytics was second was in the upper right-hand image. There was a fire between the racks. The other technologies were at the ceiling. As the smoke rose, the video analytics camera in the corner had to wait for the smoke to break the top of the racks before it could start analyzing the image. The other detection technologies detected before it. Now, had this been an actual application where early detection between the racks was required, the camera could have been placed in the location that we're viewing now to see the smoke rising from the floor. So video analytics detected 100% of the fires were 88% of the 88% of the time first. And you can see why. The analytics is analyzing the image floor to ceiling. As the smoke's rising, as soon as it hits the alarm zone, it goes into alarm. So the way that we lay out video analytics systems, the field of view horizontally is close to a 90. So we start in the corners to follow the 90 degrees of the wall. The detectors are listed to 100 feet based on a 4-minute smoke emitter or a 1 square foot pan fire. So we just lay down quarter circles covering the white space, of course, where we can mount the detectors. And we count the quarter circles. That gives us a camera count, tells us what size of NVR is required. Each camera will cover 7,800 square feet based on a 100-foot radius. With flame detection, we can go out and do a performance-based design to 150 feet, stating that we're detecting a larger fire, which would be an 18-inch pan fire in this case. We discussed zones. Zones are used to increase the sensitivity, allow us the highest sensitivity available and the lowest potential for false alarms. So a zone extends from the camera view out to as far as the camera can see. It's a virtual, and there's a virtual plane at the bottom of the zone. So we're normally looking at the bottom of the zone because the fire is going to occur below the zone. So the smoke is generated, it rises and is tracked by the analytics. As soon as the smoke reaches the detect zone, the system goes into alarm. The zones can be any shape or size, can be either blocking or detect or alarm. So the blue zones are alarm zones for smoke. The red zones are the blocking zones for flame, where welding or cutting are occurring. So say that there's some smoke started in the pallet of paper, with paper down at the bottom of the screen. The smoke rises, it's detected, tracked. As soon as it touches the smoke zone, the system goes into alarm, way before it hits the ceiling. If there's a flame generated on this paper, the system will go into alarm because we're only blocking flame in the two blocking areas. These zones can be set on a schedule, so nights and weekends, the system is wide open for alarm anywhere in the field of view for flame or smoke. You can also set up a motion detect zone for additional security. But one of the relays on the camera can be motion. The other relay, alarm relay, can be smoke and flame. This is an example of zone use. This is the Orion spacecraft in Houston. This is a mock-up, actually. The entire warehouse was covered by video analytics cameras. A smoke emitter was lit on the far side of the module. The smoke rose. As soon as it hit the zones, went into alarm. So this is an example of a configuration file. You have the zones set up for alarm. At the top, there's a blocking zone for movement of the lights. That's not the hazard. And then down at the bottom, you can see the sensitivities and time delays. Now, when the system is commissioned, we like to use a 4-minute smoke emitter if possible. Fog generators can be used. We recommend alcohol be used because it's a clean fire if possible, or motion zones just to show that the analytics are working. Once the system is commissioned and the settings are set, we generate an audit report. At 6 months, we run a verify routine in the software to confirm that the settings are the same as commissioning. And the system also generates a sketch of the camera's field of view. So that's all checked in the verify function. Annually, we run the same verify report to make sure that everything's the same. You have an image, the sketch matches. We also, as I indicated before, force alarms to the relays on the cameras to confirm communication between the camera relays and the fire alarm control panel. So, video management software is available to view the camera video live. Also can put a plan view in the software so you can see where the detectors are located. A timeline is used to identify when events occur, and you can go into the timeline and download events. So smoke is blue, flame is red, green is motion. The system is recording 24/7, 365, first in, first out. With the new servers, they're about 12 to 18 terabytes, so you get about 45 days worth of recording. Now, the new flame detector series covers IR3, IR3H2 for hydrogen, and UVIR HD. So all three versions have HD video cameras, or you can purchase the detectors without the cameras if they're not used. The detectors with the cameras can be monitored with the video analytics. The reflected flame is very helpful in applications where the fire could potentially be outside of or obstructed and not within the view of the detector itself. Oil mist could potentially be detected prior to an explosion or flame where the detector is not used. and you're detecting before the fire occurs. Competitively priced, the temperature range, -67 to 185 degrees F. Very high false alarm immunity. The system can be used for millisecond or high-speed operation connected to a high-speed deluge system. Class 1 Div 2 housing and stainless steel, so it can be used in areas where you have chemicals. 0 to 20 output, alarm and trouble outputs. This is all on board the detector itself. There's an RS-485 connection to the detector to view live video, download video from the detector itself. The detector has flash memory that is being monitored, that is recording 24/7, tracks events. When there's an event, it's tagged. A minute prior to the event is recorded, plus 3 minutes after the event. And that information can be downloaded through the RS-485. The RS-485 can be daisy chained through the detectors, and you have a central location for connection to the RS-485. This can be used in 3 ways. Number 1, with 24 volts DC and relay monitoring with no NVR, so it's recording on board. You can also use it with an NVR where you're recording the video onto an NVR, or you can use it with video analytics. We recommend that the analytics only be used indoors. So the first way that it's used is 24 volts DC, and then trouble and alarm contacts monitoring, and then RS-485 at a central location so you can connect in, adjust the settings, view live video, and download the event videos. So in here, the same thing, fire alarm panel, 24 volts DC, contact monitoring, and then Ethernet run non-PoE, the power is from the panel, and then down to an NVR for recording, or a server that's analyzing the image. There's also a relay, an IP relay that's used for the analytics alarms. So when the triple IR is an alarm, you'll see a red flashing on the outside of the screen. This is an indication of an alarm for the triple IR. And then the video analytics also is an alarm. Sorry about that. Okay. So this is a video of the analytics monitoring for smoke through the triple IR camera. Very good image. This is an event that we caught at a waste facility. We installed the camera on a Thursday. We went back the next Friday to view the events on the detector itself. There was one event, and that was a fire that occurred the day after we installed the detector. You can see just there down in the bottom right-hand corner, a small flame ember jumped into the screen, caught a piece of paper on fire, was detected very quickly by the triple IR detector. So we had proof of what the event was to show the end user. So standard applications for radiant energy detectors. I won't go into these, primarily industrial. So the triple IR or any of the detectors can be used outdoors or any application. We just don't use the analytics outdoors. Engine test cells are a great application for the detectors with the video analytics. We can monitor for oil mists, reflected flame, motion, see anything that happens. So don't blink. This is high-speed detection. So about 5 to 9 milliseconds with UVIR, about 20 to 30 milliseconds with the IR3. So very fast detection. You'll see the light comes on, when the detection occurs. Connected to water supply, solenoid, and there's your high-speed deluge system activation. All right. Now, in looking at the reports provided by Chris Cloney at dustsafetyscience.com, his reports are very helpful in analyzing the industry. We see that fires are happening about 3/4 of the time, where it's the explosion events are about 1/4 of the time. So we're looking outside of the equipment itself and looking at the space where the combustible dust can be present. NFPA 652 for combustible dust that came out in 2019 requires thermal monitoring of anything in the space where there's combustible dust that can reach combustion temperature. That's pipework, processes, bearings, motors, anything. So thermal radiometry can be used in those locations. So the thermal radiometry in this case is an IP camera powered over Ethernet. On the left-hand side, there's 2 thermal radiometry cameras. These are FLIR imagers connected to an IP device. So they can just an Ethernet cable to these locations or to these detectors. A central relay is used to notify an alarm. So alarm can be on temperature increase or temperature decrease. The camera on the right-hand side is a video camera on the right, and then a FLIR imager on the left. So these are the images that you get from we call that the OWL. So detection range is wide, -40 to 550 degrees C. For each camera image, you can have up to 20 areas of interest. So each area of interest could be monitored for its individual temperature and alarm on temperature increase or decrease. And for each area of interest on each camera, you get a graph of temperature over time. So that can help with maintenance for the customers. We're also seeing this requested in lithium battery energy storage facilities. This is very helpful when you have a large facility for the first responders to be able to identify where the fire is occurring with all the smoke that's going to be present. Video analytics coupled with thermal radiometry makes a great fire watch, compliant with the NFPA Firewatch standard. So you have thermal imaging in areas where you have a lot of cable trays, cable spreading rooms, up above the switchgear racks where you have a lot of cable trays. It's very dark, difficult to locate detectors. Video analytics, the left camera there, that's a standard video camera. The video analytics can monitor that image for flame, smoke, reflected flame, motion, oil, mist. So this can be used as a primary fire watch, or when personnel leave the site or the area and you're required to have 4 to 8 hours of fire watch after the work. This can be set up, monitoring in a central manned location. There are relays, one relay for the thermal radiometry, another relay for the video analytics. We're seeing a lot of use for thermal radiometry. There are no standards for thermal radiometry being used for fire detection, but there are thermal radiometry committees that are working towards standards. thank you very much for your time in viewing this presentation. We appreciate it. Todd, you have some questions?
Yeah, thank you. Thank you very much, Rick. Very informative webinar. The technology for this video imaging and analytical video, it's just really come a long way in a very short time. Some great information. We do have some questions that have come in, and I want to mention to anybody that's listening, please feel free to type in any questions in the chat that you if you have any questions, feel free to go ahead and type those in now, and we'll field those questions to Rick, and we'd be happy to stick around for a little bit and answer any questions you guys have out there. I guess to start, Rick, one of the questions came in. You mentioned a couple times with indoor and outdoor applications. Are you saying that both smoke and thermal HD is not to be used for outdoor applications? Did we understand that correctly?
The radiant energy detector by itself can be installed outdoors or indoors. We just don't recommend using the video analytics outdoors because we can't control the natural lighting.
Gotcha.
Thermal radiometry cameras can be used the thermal radiometry cameras can be used indoors or outdoors, and they're rated for extreme environments.
Okay, perfect. Thank you. You talked a little bit about, had a nice slide kind of giving an understanding of how to do a layout and design and location of the cameras and that sort of thing. I'm not sure if you got into it at all, but what's the typical elevation that you would install these video analytical cameras at?
We mount the cameras above the highest hazard in the space, so the detector does not have to be installed at the ceiling. And you can see from the field of view, we have a wide viewing angle horizontally. So we install the cameras a few feet above the highest hazard, so we can see any smoke, oil mist, or anything rising from the highest hazard itself. And we can see down to the floor and usually around it, depending on the amount of cameras installed.
Okay, and to follow up on that, was there a maximum height? You talked about installing these just above the hazard. I mean, is there a point where it's just too high, or you have to do multiple levels of cameras?
There is, yeah. So we would evaluate the field of view, the height of the hazard itself, and determine whether we need multiple levels of cameras, and that's sometimes the case, yeah.
Okay, great. You mentioned a lot of different, applications that we would utilize these cameras, and you showed a lot of unique locations, could probably be very dirty environments. Is it a typical one of these cameras, if the lens gets dirty, is that going to activate some sort of trouble condition, or is there a guidance on making sure that these are clean or anything like that?
You do have video from the cameras through the video management software. You can see if the video is starting to get the lens is getting dirty. The software will go into trouble for a dirty lens where the visibility is below the ability to analyze the image. If it's out of focus, it'll go into trouble as well. In some applications, in areas with coal or a lot of dust, the customer usually directs air on the lens.
Okay. With the IIIR HDs, how long of a video time is recorded with those particular detectors for a specific event?
Okay. All of the detectors with HD video capability have an onboard flash memory that tags events and records a minute prior to the event and then 3 minutes after the event. So, and that can be reached by the RS-45. You don't have to have it connected to an NVR.
Okay, so you said 3 minutes after, and was it 30 seconds before and 3 minutes after?
It's 1 minute prior, 3 minutes after.
Excellent. Okay. How do you configure the settings on that same IIIR HD detector? Is that a difficult process?
Yeah, so
is that pretty straightforward?
It's very, very simple. So it's through the RS-45 connection. There's a software tool that's used. There are low, medium, high, and extreme settings. There are time delays available. Those are all configurable through the software and then connected to the camera through the RS-45 connection. And that connection can be daisy-chained between the detectors. You don't need, because there's a different address for each detector.
Great. Okay. Okay, that makes sense. I think you had mentioned at one point, we talked a little bit about air changes and so forth. Is there a maximum number of air changes that can occur in a volume before these type of detection or another type of detection would be required to be utilized?
Yeah, what we do is we'd like to light a smoke emitter in the space. We don't have any documented guidelines as far as airflow. If it's a high airflow and you know that it's going to break up the smoke, actually airflow does help the analytics in some cases. In the shipboard engine rooms, there is airflow in the space. We've lit smoke emitters on many times in the engine rooms. The smoke goes up and then it moves sideways, and it never gets to the smoke detectors in the overhead. But it does direct the smoke into our alarm zones. So we like to do tests. If a customer is interested in video analytics, we'll look at the airflow. If it's obviously too much, we won't be involved. But we can do a test with a 4-minute smoke emitter or a fog machine to see the movement of the air, if it's going to stick around long enough for us to be able to detect.
Sure. Okay. For the Li-ion applications, can you comment on what has been experienced and possibly the placement of VID and so forth?
On the what application?
The ion applications, the thermal radiometry for lithium-ion batteries. I'm guessing lithium-ion applications.
Oh, lithium. Okay. Yeah. Okay. The lithium-ion, the energy storage systems. So yeah. There are a few applications. So you have containers. So a few, depending on the size of the container, you could use 2, 3, 4 thermal radiometry cameras in those spaces to identify heat buildup. So you'd set the temperature as low as the alarm point as low as you can, and that will give you an indication of if there's thermal runaway. From what I understand, inside the cells there are monitoring circuit boards, but if it does have a thermal runaway, that circuit board is going to be fried and loss of communication. We're also looking at thermal radiometry cameras, or possibly flame, radiant energy flame detectors, looking at the containers outside from a power pole, looking down at the container. Some of the containers have flame vents where the flame will be released that a IIIR detector would see. Certainly the radiant energy detector would see that. And then if you have a large facility where you have rows of racks, there are HJs out there that are requiring thermal radiometry looking down the racks, down the aisles of the racks. So when there's a fire, there's going to be a lot of smoke. Thermal radiometry can see exactly where the location of the fire is to direct the first responders in.
Oh, that's interesting. Okay. The cameras themselves. If we had a customer that was buying, let's say, just security cameras, and was utilizing, or wanted security cameras anyway, do you have an approximate upcharge or percentage of cost impact if they wanted to, instead of using standard security cameras, upgrade to these type of cameras? Roughly, I mean, is there any rough estimate to that?
Do you mean upgrade to a video, an approved, listed approved camera from? It would be
from a standard. Standard.
It's roughly $800. Yeah, there are different levels of cameras. If you go with a high vision camera, they work. They're very low cost. If you go with something that's very robust, like an Axis camera, you can get those for $600, $700, $800. So it depends on there are different types of cameras and quality and pricing. What you could do is add video analytics to the camera itself. If it's supplemental application, you install the camera that you want. It has to be ONVIP compliant. We would monitor the video from that detector or that camera itself with the analytics. That would be the most economical way to do it.
Okay. Okay, so it also, like you said, there's a lot of different options with the different cameras, so it really depends in that scenario. So, okay.
That's one of the reasons that we like to get involved with the project. Yeah, since there are so many options, that's one of the reasons that we like to get involved with from the concept to determine if you want to use video analytics, thermal radiometry, or IR detection with analytics. There are a lot of options out there now, and it's very specialized.
Right. Excellent. Well, yeah, if any of you have any additional questions, any of the listening audience, you can certainly reach out to Rick. His email address is on the slide in front of you. Rick, again, thank you so much. A very informative and very technical presentation, but certainly had a lot of great information that I also learned about these that I was not aware of. So thank you for that. Want to thank again our sponsor, BFPE International, for sponsoring today's webinar, and appreciate everybody's attendance today. So thanks again for listening. And again, as a reminder, this is recorded and will be available on the FSSA.net website. And we appreciate your attendance. And I'll hand it back over to Becca. Becca?
Awesome. Thank you, Todd. You did say everything that I was going to say, that the presentation will be available on the FSSA website within the next week. And keep an eye out for information on the next FSSA webinar, which will happen in 2020. Thank you, everyone.